So we just went through the explanation or proof or justification for why xk is a random variable. And so we identified the sample space omega as the set of all strings of length n with zeros and ones, and those track exactly where each particle is, right? So every particle is labeled. We know exactly where it is left turn or right turn. Left turn is a 1, right turn is a 0. And then we established that xk is a function from the sample space to a state space, right? So this S represents all the possible values that xk could take. Xk is sort of our experiment, right, or the observed quantity of interest. And that quantity can be just a number from 0 to n, the number of particles in the left urn, regardless of what their labels are. And then xk is the function, right, of the omega I, and each omega, which is in sample space, is just a vector where each component, omega I, this corresponds to the ith particle, right, is either 0 or 1, right? This a 0 would mean that particle I is in the right urn, and the 1 would indicate that the particle I is in the left urn, right? So when you sum them, you pick up the ones and you get the number on the left. And so we're trying to get to hopefully a calculation like this, right? And you know, at this point it's kind of legitimate that I wrote that, right? This where, you know, you can take an expectation of a random variable, and so how would I do that? Well, I would need its distribution, at least if I had the distribution, and then I know how to write this down. So how would I write it down? Well, it would be just the sum. So, you know, think about it. Xk is a discrete valued random variable. So I'm just going to sum over all its possible values. So this little x is going to represent the, you know, realization or the potential value of that xk could take, right? And it takes values in the state space S. And so pretty easy to write the expectation, right, if you know all of these things, right? And these probabilities, right, that's the distribution right here. And if we knew it, right, then we're kind of all set. And the question is, what is the distribution of xk? And that's, you know, a little less clear. And so this plan is kind of maybe questionable a little bit, but you know, maybe we can simplify the problem a little bit, right, and see if we can at least write the distribution for some of the xk's. Let's say x0. Or maybe x1. So, you know, x0 is, now what is it? This is the initial value for the number of particles on the left. And if that picture represents sort of our initial starting point, the answer there seems to me to be 3. And what's the distribution of 3? I'll pause here. We could try to think about it. I mean, 3 is just a number, right? So we know what it is, so it's not even really random. So it's just probability that x0 is equal to 3 is equal to 1, and the probability that x0 is equal to 4, 5, or any other number is going to be 0. Right, so in fact, you know, for a known quantity, there's not much of a point of computing an expected value, right? So the expected value of x0 is just 3, right? Where at time 0, we know that there are 3 particles in the left urn. And so the first interesting sort of problem is, what about the distribution of x1, and then what about its expectation? So here, you know, you have to think a little bit. So you scratch your head and you say, well, you know, what are the possible values of x1? Well, x0 was 3, and then on the next step, I got up and I either moved something from the left to the right or from the right to the left. So if I moved a particle from the left to the right, I would have ended up with 2. So, you know, x1 could potentially be 2, or it could be 4, right? How do you get 4? Well, I would have gotten up and by random I picked something on the right and moved over there and gotten 4. And the question is, with what probability do these events happen? Well, to get 2, I must have picked something from the left. There are 3 out of 7 possible picks, so 3 out of 7. And with what probability could I have moved a particle from the right over to the left? Well, I mean, the cheat is just to say one minus the other, because those are the only possible outcomes, but this event really does correspond to me picking up a particle from the right, moving it over to the left. There are 4 here out of 7 total. So you have this. So this looks encouraging. Let's maybe let's write it for the general setup. Let's say we're starting with some number of particles x. Right, so I'm going to use little x as my starting state. It's 3 in this example, but in general it doesn't have to be. And let's say there are n total particles. So x1, we either go down by 1 or go up by 1. Right, so those are the 2 possibilities. I picked one from the left and moved it to the right to go down 1, or I picked one from the right and moved it to the left to pick up 1. So what are the probabilities here? I'll pause for a second to let you think about it. But the answer is just x over n. That's the probability. You know, if there are x particles on the left, to go down you have to pick from the left, and that happens with probability x over n. To go up you have to pick from the right. How many particles are on the right? It's n minus x. And how many particles total? It's n. So presumably we can even get the expected value of x1 here. Right? If we know the starting value is x, we have the distribution of x1. There are only 2 possible outcomes. I suggest you, as an exercise, try to work out what that is, because in the homework you'll have to do something a bit more complicated even. And once you get to x2, it becomes quite a bit harder. How many possible outcomes are there for x2? Well, I could have gone down by 2 by moving 2 particles over. I could have gone down by 1, could have gone up by 1, could have gone up by 2. And as you go, right, it becomes more and more complicated. So, you know, while I think it's possible to write down the distribution of xk, it's certainly not going to be very easy. And I'm certainly not going to be able to fit it on this board. And what I'd like to do is show you a different approach using which you'll calculate this. And that's something called first step transition analysis. That's what I'll cover in the next segment.